One of the key aspects of game development is the collection and interpretation of data at runtime to choose results in how the game proceeds. Whether that means selecting which animations to play, how much damage should be dealt to a character, or what kind of gameplay effects should be applied, it's crucial that developers construct their data in a way that allows them to easily read and write from it, and to make decisions based off of it. For those new to the channel, my name is Devin Sherry, and I've been working in the games industry for almost a decade, where I've been using Unreal Engine professionally throughout that entire time. Today I'm going to show you how to use Choosers, a plugin from Unreal Engine that allows you to read and write data to an asset, and then use that data to choose results that you need for your game. So let's jump into the engine and get started. Now before we jump into the tutorial, let's set some expectations. We're going to be working with Unreal Engine 5.6. The gameplay and the game framework that you're seeing here is from my personal project, so a lot of the setup with the Gameplay Ability System plugin, the character controller and the controls and the camera and all that stuff is all going to be done not through this tutorial. This tutorial is only going to be focusing on the chooser aspect. So what we're going to be working on, and I'll show you this in game right now, is setting up hit reactions for when we're getting hit by these spheres that are coming at us. And each sphere represents an attack type that is mapped to a gameplay tag, and we use the hit results of the sphere hitting us to pick the appropriate animation. So if we're getting hit from the front, we play a reaction backwards. If we get hit from the left, we play one in that direction, and then to the right, and as well as to the back. And we have two spheres because one's going to represent melee attacks, and the other one represents an elemental magic attack, just for the sake of having differentiations in our hit reactions. So we have two severities, quote unquote, on that, where we have these different types of reactions being played. And we use choosers to take that data from the hit result in order to play the appropriate hit reaction. So now that we know what we're going to be doing today, let's go ahead and get started. So to begin, we need to enable the Choosers plugin. So let's navigate to Edit and then Plugins, and let's search for Chooser. And I'm on Unreal Engine 5.6, so depending on what time you're watching this and what engine you're working with, you may also see a UAF chooser. That one's experimental. That has to do with the Unreal Engine animation framework. That's not what we'll be working with today. We want to work with just the base chooser plugin. So right now I already have it enabled, but when you enable it on your side, you'll be prompted to restart the editor. So go ahead and do that and then jump back in. Now that we have the chooser plugin enabled, let's go ahead and actually create a chooser table. So in our content browser, let's go ahead and right click, go down to miscellaneous and up to chooser table. And when we do that, we get a wizard that prompts us how we want to construct the chooser type. So by default, we have three options. The first being an animation chooser, which kind of sets up and constructs it under the assumption you'll be working with data involved with animation. And even though we are going to be using animations to actually use it and use a chooser to pick an animation montage based off hit results and get hit reactions, we're not going to be using the animation chooser option. We're going to use a generic chooser because the generic chooser kind of lets us construct the input and output data as we want, rather than setting up some base values for us. And the last is a no primary result chooser, and that just assumes you don't want to actually spit out a result, but you want to kind of change or alter the input data based on the other parts of that data structure. So since we're going to be working with animation montage and actually spit out a result, we're going to go ahead and select generic chooser. Now we're going to leave the result type as object of type, but you can also choose subclass of. So that means you either want to choose a class or you want to choose an object. So for us, it's an animation montage. So let's go ahead and select anim montage. And now for our parameters, we can go ahead and add, and again, we're going to have a class parameter and a struct parameter. So what you can do is input a class. So for example, with the gameplay animation sample project, they actually take in the character class to get some data from that class and variables and things like that. Or you can use a structure, which we're going to be using for this tutorial. I'm going to show you the hit reaction chooser struct that we're going to create. And we can use that as our input. So we tell this the chooser table, hey, use this data, interpret it, and spit out the results based on how we're evaluating it. So we're going to select struct, and we're going to find our f hit reaction struct. And I'm going to show you what's in that structure in just a second, but that's going to be our input. So we can go ahead and now create the chooser table. And the naming conventions that we've been using is CT for chooser table as the prefix, and then I'm going to just call it hit reactions. So let's go ahead and double click it and open it. And I'm going to expand it, not full, just because my camera might get in the way, but here is the official chooser table. Now, before we dive deeper into the chooser table, let's go ahead and figure out exactly how we'd use our struct. So before we continue with that chooser table, let's get more context about the structure and the data types that we're working with and feeding into that chooser table that lets us take hit result information and spitting out a hit reaction based off that data. So I'm using a custom blueprint struct called fHitReactionChooserStruct. And for those unfamiliar, you can create your own structure in Blueprints. If you navigate to your content browser, go down to Blueprint and select Structure. But I already have one made, so I'm going to just double click and open it. And for further information, choosers only let you use a certain amount of data types, booleans, enums, gameplay tag containers, object classes, floats, and objects. You can expand upon that in C++, but that's the core set of data types that it supports. And so for our structure, for our example of hit reactions, we're using a float and a gameplay tag container. So the float represents the hit angle. So in our hit reaction gameplay ability, I'm calculating the actual hit angle, so whether or not it's in front, back, left, or right. And then I'm using an attack type tag container that's associated with these spheres that lets us know what type of an attack it is. So for the sake of example, we're saying one sphere is a melee attack and the other is some sort of magic or elemental attack. And we're using that tag as a part of a switch to let us know what type of hit reactions we want. So whether or not it's a stronger hit reaction or a weaker reaction. So now that we know what type of data we're working with and why, let's jump back into the chooser. So back in our chooser table, let's take a look at the general layout and what the table settings mean, and then we'll begin creating our actual chooser table logic. So by default, we can go to our table settings and look at the result type and the parameters that we're using. All of this should be set by default depending on how you constructed that chooser table when creating the actual asset. So just to recap, we're working with our object type result type, and the result is of an animation montage or animmontage. And then we're working with parameters, and with parameters we're using our struct, which is that fHitReactionChooserStruct that we just discussed, and we're using it as our input direction. And so with direction you could say input, output, or input and output. And so depending on how you want to use the structured data, this could change. But for the sake of our example, we're only taking in that data. We're not going to be outputting it or writing out to it or changing it in any way. So we're leaving the direction as input. And so then now we can use this data to make our chooser table logic setup. So when working with chooser tables, we have columns and we have rows. And rows represent the results, while columns represent the data that we're evaluating to then spit out said results in our rows. So let's begin with how to use the columns. So the columns represent those data types that we talked about earlier: booleans, enums, floats, gameplay tag containers, objects, object classes, and all that good stuff. And so we have options to filter using those data types, but we also have options that output those data types. So in those cases where we want to input and output, so read and write, we can use those output values to say, okay, write out to this structure that this is now false, or that this value is 10 instead of 12, whatever the case may be. But for the sake of our tutorial and our needs, we're going to be working with filters, because filters allow us to say and evaluate within each column. Now, if something is true, if there's a float within a specific range, then make this result spit out this montage, for example. So let's start with a data type that we don't support within our hit reaction structure, which is a bool. If you remember, we only support floats and gameplay tag containers. So when we select a bool, we don't really have an option for anything to work with it, because again, we don't support it within our fHitReactionChooserStruct. But if you did have a boolean, you can kind of select options here. You can see how it's binding. You can see the default row value if it matches any. It could be true or it could be false, and all of that good stuff. And so based on the data type, you can kind of interpret it in different ways. So if we were to actually add a column for a data type that we do support within our structure, say for example, float range, we can then select this, go to struct, and then select hit angle. And so now we can use hit angle to then interpret a result. So what we can do now is, for example, add a row for our result. So results can be a couple different things. It could be a hard referenced asset. And in this case, the asset represents the result class that you set up for your chooser table. So again, for our table settings, it's an animation montage. So if I were to select asset, you can see now all the options here are animation montages. But if I were to change this to something like an animation sequence, these results are now animation sequences. But we'll work with animation montages, so let's put that back as it was. And now you can see when we add a row, we can actually then set up information for these columns. So again, for Booleans, for things that we're not using, you can set this to any or false or true. So if it doesn't matter for a certain result, whether it's true or false, you could set it to any. If it needs to be false, you can set it to false. If it needs to be true, you can set it to true. But for floats, we can work with angles, with ranges. And so in our case, a hit angle, we can say whether or not it's within a low threshold or a max threshold, and then interpret it as whether or not we're being hit from the front, the back, the left, or the right. And we'll go over that very, very shortly. But we can also add then columns for enums. And again, we don't have an enum to support this, but based on your enum, you can then say whether or not it's equal to it, or if it's not, or it could be any. You can also add a column for gameplay tag or gameplay tag query. So depending on how complex of a comparison you need to make with a gameplay tag container, you can choose one or the other. Typically I use queries, but I believe for the sake of our example, we're going to use a gameplay tag. And so now, again, because it's a supported data type in our structure, we can then say attack type tag container. And here we can then make our comparisons for the gameplay tag. And we'll go over that very, very shortly. We're just going to go over the rest of the result types here for our rows. So if we were to add a new row, we just covered assets, which is a hard reference to our asset of our result type. You can also do a soft reference, but you gotta be careful when you do soft references. You need to load them and evaluate them before you use them. You have options for classes, but that's only if your result type is set to a subclass of. If you remember, we're using an object type, not a subclass type. Next, you can evaluate a chooser. So instead of selecting a specific asset, we can then tell it to evaluate an entire other chooser. So you would have any other compatible choosers here selected. And the other option, and the one we'll be using today as well, is a nested chooser. So if you don't want to create a whole other chooser table, you can create a chooser within a chooser, for lack of a better term. And you can then create a new nested chooser, and then within it, edit it, and you'll see a whole new kind of sub chooser table. And that's what we're going to be using for our example. So now that we have a better idea of how we're going to be using the chooser table, let's go ahead and talk about how our hit reaction gameplay ability works and how we're feeding the data into the chooser table, and then we'll actually be setting up the chooser table logic. So the beginnings of the chooser logic come from the hit result of these spheres. So these spheres hit the player character, but they also contain an attack type tag container that lets us know whether they're a melee hit or if there's some sort of magical elemental hit. So let's just go over quickly the pipeline that we're using to feed into the chooser that we'll then create from scratch. So it all begins with the actual projectile. So this is something I've built off on my own, so we're not going to talk too much into it. And we're using the gameplay ability system plugin, so we have access to gameplay events. And so when we're doing a hit, we're sending a gameplay event to the actor that we're hitting, and it says custom event for on hit. And in this, we're passing in the attack type container tags. So this is whether or not it's melee or if it's a magical or elemental hit. And then I'm passing in the hit result as target data, and we're passing it through this gameplay event that we're sending to the actor. And our character, the player character, has a gameplay ability granted to them by default. And this receives this gameplay event for the on hit, takes the target data, the hit result from that data, and then calculates the hit direction angle from that hit result. So if we jump into this, we're doing a lot of vector math to do the dot product and cross product, getting the a cosine, and then taking radians to degrees, multiplying it by the sine of the cross product of the hit result, the impact point, the impact normal, the unit directions between all of them, and all that good stuff. And then taking that output angle, so this gives us a signed angle, so somewhere between 0 and 180 degrees. And it's signed, so it could be negative 179 or positive 5, whatever it might be. And then we're taking that angle and feeding it into the chooser via the structure that we've talked about before, the F hit reaction chooser struct. And we're also passing in the instigator tags that contain that attack type. And then this is how we're evaluating the chooser. So what we can do, I'm also going to show you how to evaluate the chooser from scratch. You can right click, type in evaluate chooser, and then when you select the chooser, you get the option of which chooser you want to evaluate. So I'm going to pick CT_hit reactions. And here we have different options. We have mode, which tells us we can give us the first result, or you can give us all results. So there could be cases within your chooser logic that allows multiple results to pass those evaluations. So you could choose all results, and when you do this, that turns into an array. So we're going to do first result. And then there is the option return soft object reference. So we could that, and this makes it the result a soft object reference if we wanted. But again, we're just going to use the hard reference for now, and that's okay. So this is the chooser struct that we're going to be working with. This is the default chooser that I created to showcase the actual setup. So we're going to go ahead and nuke this, and we're going to replace this setup here. And then we're going to pass in the result into our play montage and wait task inside of our gameplay ability. And then resave, compile. And now when we play, we're not going to see any sort of hit reaction play because our chooser doesn't spit out any results for us. So now we're going to get into the meat and potatoes of setting up this chooser table. So let's get back into the chooser table and set this up properly. So now back into our chooser table, let's go ahead and set up our column and row data so that we can get the appropriate hit reaction montage that we want based off the attack type tag container and the hit angle that we're getting from our hit result. So the way I want to construct this is that on the high level part of the chooser table, I want to take in the attack type tag container and use that tag to switch into nested choosers that will then take the hit angle and use float ranges to determine whether or not it's the front, back, left, or right, and take in the results to spit out the animation montages that we want. So let's begin with the melee attack montages, and I'll show you what these look like. They're labeled as large because they do have some displacement in the root motion. And again, I'll link in the description the Unreal Engine Marketplace link for these animations. So big shout out to the people who make these animations. I'm not good at that. So we have our front, we have our left, we have our right, and we have our back. These are the animations that we're working with for melee attacks. So let's go into our chooser. We're going to start off with a gameplay tag column, and we're going to select our option from chooser, the attack type tag container. And on the right hand side, we have the column properties that lets us know how we want to use this data. So the tag match type, we want to do all, and we want to make sure it's match exact. You can also invert the matching logic if you don't want to match exact. And then we can go ahead and add a row. And so the row option we're going to do is a nested chooser. So again, depending on the needs for your project, you might want to not use a nested chooser and make sure you create a whole separate chooser asset for these options. It depends on if you're okay with, exclusive checkouts among other developers, or if you want to kind of encapsulate this all into the same chooser logic. So for the sake of organization and how I want to do this tutorial, we're going to create nested choosers for the different attack types. So when you have a nested chooser, you can do new nested chooser and give it a name. So I'll type in melee attack types. And for the actual column for the gameplay tag, we're going to go in and we're going to select the gameplay tag. We have test dot and then chooser dot attack type. So these are the two attacks type tag containers that we're passing in through those spheres. So let's start with melee, and then we'll do elemental next. We're going to select melee, and now we can edit the nested chooser. And now we have a brand new pseudo chooser. Again, it's a sub layer of the main chooser. And here we're going to use float range, and we're going to map that to our hit angle that we're going to pass in. And now we can add the actual row type for our asset. And again, we're going to be using montages. So let's begin with the front. So let's hook in our front result. And now for the front, we're going to be working with angles between negative 45 and 45 degrees. You can change this if you find different numbers that work better for you, but that's what we're working with. And what we can do is Control D for the next row, and we'll do left. So let's select our left animation sequence, not sequence, our montage, excuse me. And we're going to go from 45 to 135 degrees. Let's duplicate this row. Let's select our montage for our right direction. Now we're going to change this to negative 135 to negative 45 degrees. And so be careful with float ranges because it works with minimum and maximum values. And when you work with negative numbers, the larger negative number is, negative 135 is the smaller number compared to negative 45. So just be careful with that. You might get inconsistent results if you don't make that check appropriately. And so for the back direction, we're actually going to have two different rows for it because we want to map it to two separate ranges. So the first range will be from negative 180 to negative 135. And then the second range will be from 135 to 180. So let's leave that. Let's confirm that we have all our setup here for our chooser. I'm going to just print out the chooser animation montage selected, its name, as well as printing out the hit angle so that we have some good comparisons to ensure we know what we're doing and getting the results that we're expecting. So now if we play in editor, the first sphere will be our melee attack type. So let's see if this works. So we are getting the front. We are getting the back. Are we getting the left and right? Looks like we are. Perfect. So now if we actually go to the other one, the elemental attack type, we're still not getting any results. And that's because we didn't set up the chooser logic for that. So let's jump back into the chooser table. We can jump back up to the parent chooser. Now we can duplicate this main row. We can change the gameplay tag type we're using. So tag type dot, and then we're going to use elemental. And now we can create a new nested chooser, and we'll call this elemental attack types. And what's cool about choosers is you can copy and paste rows into separate parts of the chooser. So I just duplicated all those ones from melee attack types, and I'm going to paste them into elemental. Now we have a different subset of animations that we're working with for our elemental damage types. They're not the large reactions, they're just the default normal kind of reactions, like sort of in place. So let's go ahead and make sure we have all of them selected, and we'll go ahead and edit just so we can preview them. And of course they open up on a different window. Hold on. So here's our front. Here's our left, which is kind of backwards because it's coming from the right direction. And our right is coming from the opposite as well. So we got to keep that in mind when we do our chooser, that these are opposite directions. And then we have back. So let's start with the front. So again, we're in our elemental attack types nested chooser. And we could just hook in front. Sorry, this is the back. But let me make sure we have front selected. Excuse me. So there's our front. And again, left and right are backwards because of the way the animations are authored. So now for our left direction, we're actually going to be picking the right. And then vice versa for the left. And then back will always be back. So let's make sure we have that selected. And then put it into our chooser. So now, if we play, we'll still confirm that our melee attack sphere is playing the reaction. But now if we get hit by the elemental, we're now playing different types of reactions based on the direction. And it seems to be working as intended. Let's just get the last direction there for behind. Perfect. So that's working all as intended. So that's our chooser table. So just to recap, we have a high-level chooser that's taking in the attack type tag container and doing a switch based on which type of attack gameplay tag that we're working with. Once we know which one we're working with, we jump into a sub-nested chooser and take the hit angle that we're passing in, and then based off that angle range, we're saying we're playing a front, back, left, or right hit reaction. And again, it's all constructed within our gameplay ability when we take in the hit result from the sphere, and we calculate the hit direction angle using vector math and dot products and cross products, getting the cosine, converting from radians to degrees, and multiplying it by the sine of the cross product. It's a whole vector math kind of thing. I'm not going to do too much time into that. You can look that up separately. And then we feed that into our chooser, and it spits out the result of the animation montage. So now let's go over how we can actually debug choosers, because it gives you two different options that are pretty cool and powerful, and I'm excited to show you. So with choosers, you have two options when debugging. You can manually debug, or you can debug it at runtime. So first I'll show you how to manually do testing within the chooser. So when you go to the top here, you have a debug target option, and you can select this and then choose manual testing. And what manual testing does is it allows you to inject the data into the chooser to then see how it will evaluate it. So based on the data type in the columns, you can then pass in certain data to then see how it gets interpreted. So for the high level chooser, we're having a comparison for attack type tags through a tag container. And so by default, it compares it to none. And so because we're trying to find the exact gameplay tag, these both are red, which means they both fail. So none of this would be selected. So if I were to select the none and then choose the tag for the attack type, and I choose melee, you can then see the top row being green, meaning it passes, and we would enter that nested chooser. If I were then to select the attack type for elemental rather than melee, you would see the bottom row would be selected and the top one is red because it fails. And again, like I said, based on the column data that you're working with, how you can inject data for the manual testing can change. So for example, if I were to go into the nested chooser where we're actually doing a hit angle and float range, you would see by default it gives us a 0 for the manual testing. And that does pass our evaluation for the front direction because we're looking for angles between -45 and 45 degrees. If I were to change this to 90, you would see that the right reaction is being selected because it's between 45 and 135. If I were to make this -90, the opposite would be true. If I were to make this -159, you would see we would get the back direction. And if I were to make a value of 1,000, nothing passes because 1,000 is out of the float range that we're determining for our hit angle. So this is very good to get a non-runtime approach to see how your data will be evaluated. But there might be cases where you would want to evaluate this at runtime while debugging while playing in editor. So let me show you how you do that next. So now the second option to debug chooser tables is actually can be done at runtime when you're playing in editor. And you can do that when you play in editor. You can pick up the chooser table asset, bring it on screen like this. And what you can do is you can go to debug target, and then you should see any active chooser tables that are waiting for evaluation in this row as well, or in this column, I should say. So you have none, manual testing, and then the actual contextual chooser table that's active. So I can select this, and then based on whether or not I'm getting hit by the melee attack or the elemental, the chooser table will evaluate, kind of like the manual testing option. You'll see things turning red and green depending on whether or not it was successfully evaluated or not. And you can go into the nested choosers and you can see the values for the float ranges updating depending on the angle, and you can also see the rows being selected based on the interpreted angle float range. So it works exactly like manual testing, but you can actually see it at runtime and seeing the exact information being passed into it. So this is also another very powerful way to debug your chooser tables. So you have this runtime option, and you also have the manual testing option. So using these two, you'll be able to easily debug your chooser tables. To finish off this video, I wanted to show you how complex a chooser table can look like by using the gameplay animation example project from Epic Games to show you how they use choosers to take data from the player character to update information into the animation blueprint, and also post-search schemas and databases to play the appropriate animations. So again, this is the gameplay animation example project. If you're not familiar, you can download it in the Unreal Engine launcher. I'll add a link in the description below, of course. And you have this set of animations that give you different turns and places, runs, walks, jumps, obstacle course maneuvers like parkour. You have different landings depending on how high you are, and all that different stuff. And it uses chooser tables to determine which animation post-search databases to pull from based on different contexts. So to give you a high-level overview, we have this post-search database dense, which is the default chooser that's used unless you tell it to use the sparse version. And we can actually debug it like we showed earlier as well. And you can see how it works based on the actual runtime information that we're giving it. So right now I'm idling, my movement mode is on ground, and my stance is stand, and so I'm getting stand idles. And as I move, if I'm walking or running, or if I'm in air, if I'm jumping, you're seeing how the chooser is changing. And then depending on whether I'm in walk or runs or I'm in air, we might have additional post-search databases that it's selecting. So you can see kind of how the chooser is evaluating, and if I'm pivoting and jumping or moving and everything like that. And it uses this data, again, written from the animation blueprint of the character to understand how the player is actually navigating and using the character. So if it knows I'm moving, if I'm pivoting, if I'm turning the camera and rotating, jumping, and all that good stuff. And it chooses post-search data assets. And so these are all the different type of animations that we need for different contexts within motion matching and post-search data. Again, not the subject of the tutorial, but to show you the power of chooser to actually pick up animations and other data types to feed into your game logic. So I hope you enjoyed this tutorial. If you learned a lot and you enjoyed it, please subscribe to the YouTube channel. I'll also have links below to my TikTok and my Twitch, so make sure you subscribe and follow me there so you can watch me live to work on my project. And you also have a link to my Discord server where you can join ask questions about this tutorial or about Unreal Engine or just game development in general. And so thank you so much for watching, and I'll see you in the next one.